like to demonstrate how I do my NC programming in Cimatron. Let's start by opening up the CAD file. Okay, so this is a core block that's got some wire, a wire pocket here, and ejector pin holes. So we're going to do a little bit of CAD work first, it looks like. So normally I take it to NC by doing an export to NC. That preserves the file name. So in fact, let's just make sure there's nothing hidden. So up here you've got this hide show toggle, and that will flip-flop the blank screen and show you anything that's hidden. So I've got some planes that are hidden, but no surfaces or anything like that. Alright, so now we're going to go to File, Export to NC, and that takes basically the whole file and exports it to an NC document. And it's going to position the coordinate system of the core block into the new coordinate system in the NC file. So I'm going to end up with two coordinate systems here when I click accept. And now I'm in the NC environment. And then we can do a switch to CAD button. And then I'm back in the CAD environment in the NC file. So I should mention that the CAD file still exists. Let me hit the save button and I'll show you the file structure. I got a bunch of files here. I should have been a little bit more organized and made a new folder. I can still do that now. So let's click into here and hit new folder, and we'll call this core NC. And we're going to save this in a new folder. And now I'm going to point out that here's the new folder we made, here's the NC document, and if I hit the plus sign here, I can see that the CAD file was called W1564 core insert, but that file doesn't exist in this folder. I think if I right calculate, I can choose show location on disk, and that tells me where that CAD file exists, and it just means that it's associative. So if a change is made to that CAD file, the NC file will get notified of it and ask you to whether you want to bring that change in or not. Okay, so I like to do a lot of preparatory organization before I do my programming. So the first thing I'm going to do is go over here to the sets, and we're going to create some sets or levels. Alright, so the first thing I'm going to do is create a new set by criteria, color. We're going to use the eyedropper to suck up this color right here. And burn areas. Okay, now you'll see that I can quickly and easily turn those on and off. We're starting to get a little bit organized. The next one I'm going to do, I think I have to switch back to the CAD mode to do it, or sorry, cam mode. And that one is going to be under analysis, set horizontals. Analysis, set horizontals. Now I'm going back to the CAD mode, and under the sets you'll see that I have a new one called horizontal faces. That's not what I expected. That gave me horizontal faces according to the Z, which currently is not right. So we don't want that. We're going to delete the horizontal faces. I use the forward and backwards button a lot on the display. The hide and show is cool, but if you can use the forward and backwards button, it's even better. So it quickly gets you back to a state prior to hiding something. Okay, so we need a new coordinate system. In fact, this one's not really in a great spot anyhow, so we're going to go ahead and create a new UCS. And I like to use center, what is it called here? Let's see, wireframe, UCS, center of geometry. So we pick in the middle, click, and that gives me a bounding box of all these available points that I can choose. So you can imagine that if we were trying to drill water lines and we wanted to pick the back side of the block, maybe right here, for picking it up for doing water lines, that would be an easy way to do that. You can get the Z direction by clicking over here on the arrows, and then we might choose a rotation of 180. So that's how we do the coordinate system over there. But that's not what we're going for. We're going for the top center. So we pick that point, get the Z facing up, give it a rotation of 180, or I guess 0 in this case, just so the Y and X is going the way we expect. And then we're going to activate it, and we're going to call it top. Oops. T-O-P. Okay. And check mark. So now we'll try this again. We're going to go to switch to cam mode. Analysis, set horizontals. Back to the CAD mode. Look at the sets. And here's our horizontals. Now, another little trick that I like to use is right click on the set and choose hide other. So that quickly puts it on the screen and hides everything else that's not on that set. Okay, so now what I'm thinking about is what horizontal faces do I not want the ball cutter to be machining over. In other words, I'm going to finish the horizontals with a bowl cutter, and I'm going to make those check faces in order to not have the 3D programs that are using a ball cutter to like lace cut or whatever. I don't want those cutting the flats. So all I care about are faces that are big enough to avoid machining with a ball cutter. So we're going to turn a few of these off or exclude them from the set. Alright, so we're not going to want these. We're not going to want any of those. These little ones we're not going to want. You might notice I'm box picking from right to left. That means only things contained within the box get picked. It's a very quick way to select stuff. That stuff can all stay there, I think, for now. Bugsy, quit it. So I'm not sure which what surface this is or where it's at. I need to get a little better idea. So let's go ahead and unattach the ones that were selected, and we do that by right clicking and say detach, and then we can again right click and say hide other, and guess what that does? It leaves only those things on the screen. And now I'm going to hit the show light bulb, and keep in mind the show light bulb is a preview of what's hidden, so it presents to you in green what's hidden, and you have to select it to bring it back to the visible state. So for example, if I wanted to bring this one surface back, I select it, then I have to middle click. That brings it back to the visible state, but yet we have our preview still showing, so that means I can now pick another surface and middle click. It brings it back, but we're still in preview mode. Until I hit the middle click again, it doesn't commit and finish the process. And remember, I like the forward and backward button. One click, and I've undone what I did, and I'm back to where I was. But having said all that, I forgot to look at what was important, and I need to look at this again. Okay, so that little surface there won't have any impact on my 3D machining because it's very small. So I would prefer to not have that in that set. So we're going to pick them and detach those also. Again, hide other. I see I got some little spaghetti noodle over here I need to get rid of. Remember, right to left means only things inside the box. Very quick way of picking stuff. Detach and hide other. Okay, I'm pretty happy with that as my faces that I don't want to machine with a ball tool. So let's hit the save button, always a good habit. And now here's another little trick. If I now do a flip-flop on my screen, I now have the faces that I do want to cut with a ball cutter, all the 3D stuff being presented, but there's also a lot of stuff that we don't want, like the water lines and maybe the side of the block, etc. So now's a good time to create a set that we're going to call hide. New set, hide, and we'll go to the front view. We're going to set our filters to only select faces, and I'm just going to box pick from left to right means everything intersecting gets picked. And I'm going to go ahead and hit the commit button temporarily here, so I can hide that set. And now I see there's some more stuff I want to add. I'm going to hit clear selection. I didn't want to hit those planes. So again, watch your filters up here. So only faces are going to be picked. And right click on the set and choose attach. And then turn it off again. Alright, now, just to be extra organized, I want to now pick the ejector pinholes in the tops of these like water line baffles. And this is a good chance to show you another little trick. Over here, we've got your selection options, and I'm going to choose visible faces only. So that means that in the orientation that I'm looking, it's only going to pick faces that are visible from that orientation. So watch this. Oops. I'm trying to box pick. There it goes. Here comes a box pick. Box pick. Box pick. Oops. Box pick. Box pick. Box pick. Box pick. So that was from left to right, which meant anything intersecting, but you notice it wasn't picking stuff behind it because it's only the visible faces from this orientation. So I quickly picked all those ejector pinholes. And the reason I box picked was because there's a chamfer there. So rather than pick every little surface, that visible faces only works great to accomplish things like that. Okay, let me attach those. I see some space dust, it looks like, over here. I don't know what that little surface there is. But we're going to pick that and attach it to the hide set. Okay, that looks good. So now, what's left on the screen is all the surfaces that I do want to cut with a ball cutter. No horizontals, no water lines, no space junk. And it's debatable whether or not these surfaces should be there. I think for sake of demonstration, I want to hide these faces too. Well, maybe not hide them. Let's just, we're not going to include them in the set that we'll call 3D. So we're just going to box pick some of this stuff and temporarily hide it. Box pick, hide. Hide. Okay. So now the surfaces that are left are for sure the ones that I want to cut with a ball cutter. Again, maybe not this one, but we'll leave him alone for now. So we're going to create a new set. Right click, click on new set. We call this one 3D. Make sure our faces, our filters are set to faces only. And we box pick. Oop, look at that. I did that on purpose. That visible faces only will get you in trouble. You see what it did? It only picked what it could see from that vector, so it missed stuff. So be careful to turn that off when you're done, or else you'll get in trouble. Okay, so there we go. Now we're ready to write some programs. Well, actually, no, I want one more set. So normally I'll turn on the 3D set and the horizontal set. Yeah, so definitely need these ones. And I think I'll even include the rest of this. Like that. And actually, probably these ones too. Okay, in this set, I'm going to call NC. New set, NC. Set my filters to only select faces and box pick. So this set NC is what I can choose for selecting all the surfaces, like in roughing, for example. Now, we got some holes we want to patch up here, and I'm going to show you some good tools for that. There's a whole bunch of ways we can do this quickly, easily, and automated. So I'll show you a couple different ones. The first one is going to be faces boundary. I pick on a face, and we're going to change it to islands. Keep original and inside. So that gives me the inside boundary as a child surface of that parent surface. And I can hit the green check mark, the small one. I can pick this one, and it wants to do them all, which is pretty cool, but I don't want that one, so I unselect it, and it's going to give me the rest. In fact, we'll cover this one up too initially, just so the roughers aren't trying to get in there, and we'll deal with that one later. So these ones are good. I should have created a set before doing this and called it caps or something like that. Made it an active set, and whatever I create will go on that level. I didn't do that, so we're going to go ahead and say OK. And here's another thing we can show. So let's create a new set and call it caps. And by selection, or by criteria rather, change the color to brown. Okay, say OK. Now here, it's picking up the caps because they're brown. But brown's my default color for creating new stuff, so it's not a very good choice for a criteria by set. I want to change the color, but check this out. We can change it right here. We say not brown but yellow, and it'll automatically change that the surfaces to yellow, but also the criteria. So it still works, but now they're yellow. So now I think we're ready to start machining. So let's switch over to cam side, and we're going to create a new toolpath folder. Here it sets up the clearance. Let's make it 0.5 and say OK. Here we got the, well, this is NC setup. Yeah, I guess we can use that. So we're going to go with target part. So target part is only used really for doing the gauge checking in the simulator. So whatever it picks is what it's going to gauge check against in the simulator. So that's okay, I'm happy with that for now. Then we're going to go to the stock. So here we have stock as a bounding box of all the surfaces. And I think if we switch from there to box, it'll retain those values, and we can add to the Z if we want. So why does that look funny? Hold on, something don't look right. Yeah, hold on, we're going to start over here. Delete. Okay, so it was using the old model UCS, and we're trying to use the top UCS. So let's do this again. Go to part. And then go to stock. And switch over to box. There we go. So now our Z values look right. And we're going to add 0.2 to the top. Okay, now if this were in a vise and you were holding on to it by say 3/4 of an inch, and you wanted to buy an insurance policy that the ruffers are never going to cut your vice jaws, you could over here say plus 0.8. Why did that not work? Let's see. Plus 0.8. Maybe we can't do math in there, huh? Okay, so let's see. Let's go minus 3.7. Okay, so you see what's happening here is we're making a stock model stop short. Now the only bad thing about this is that if you do this now and you were to flip it over and want to use the roughing procedures, it won't see the stock there. So keep that in mind. If you're going to do setup from the bottom and expect to use a stock model, this won't be a good option for doing that. But if you want to go home and sleep good at night, knowing that your roughing programs aren't going to machine your vice jaws, the roughers will never go where there isn't stock, so they would always stop short here. I'm going to change this back though, go negative 4.6. And now I'm adding material to the bottom so that when I flip it over, it will allow me to use the roughing procedures to finish the floor. And I guess obviously in the real world we'd be machining the floor first anyhow, flipping it over and cutting the top second, but I'm just trying to explain everything for the sake of education. So let's say OK. Oh, wait a minute, let me go back to that. Edit. So because I'm 1-to-1 on my walls, the roughers wouldn't be machining the walls. So if I want a roughing procedure to cut the walls, there's got to be stock there. So let's go back to surfaces for a second. Or not surfaces, but bounding box. And let's just do like a 1/8 of an inch. And 0.2 and 0.05. So here's a quick way to get offsets according to the bounding box. Don't have them use a calculator or do any math. Okay, so now we're going to do a tool path, and I'm going to bring one in with a template. I'm right clicking, choose template, apply template, and I want an 1.25" cutter. Wait a second. So I'm choosing procedure templates rather than a toolpath template. A procedure template is an individual procedure, and a toolpath template is a whole bunch of procedures and the stock and the part. So we want this one, and let's see if we can find, here we go, 1.25" cutter. I'm not sure that's the one I want, but that's the tool that I want for sure. Let's take that for now and see what we get. Okay, so it's a rough spiral, that's what I wanted. And we're going to double click on that to edit it. And so for the part surfaces, we're going to choose criteria. We're going to take the sets, caps, NC. Okay, that's good. But this little wire pocket might be an issue, so we're going to cap that off too. So let's do a save and close. I just do a right click in geometry area, save and close. We're going to bounce back to CAD for a second. And let's see. We're going to go into the sketcher on this wall and go to let's just draw something. So we'll go from here, save there, look at it from the front, switch to the wireframe. Shorten that up a little bit. Okay, like that. And then we're going to do a sweep. Reference to that wall. Okay, so that needs to be taller. So we're going to edit, sketch, drag bring this one up like that. Say OK. There we go. Now we're going to sweep again. Faces sweep to reference. Sweep. To reference. Okay, and there's our cap surface. Now we change that to the color yellow, and guess what? It should join our set over here called the caps. And guess what else? It's already going to be selected when we go to NC. So over here, we pick it, and there it is. So that's the benefit of using selection by sets, because we can make changes and it'll automatically get included in the procedure. Alright, so let's look at the cutter next. Alright, so obviously that cutter needs to be defined as longer. We can't change the cutter while editing a procedure, so we're going to have to come back into that in a second. By the way, I'm using advanced mode if this looks funny to you, where we got pages. Wizard mode puts all the parameters in one area, and wizard mode will put them on pages. So page 1 is the geometry, page 2 is the cutter, page 3 is the motion parameters, and page 4 is the machine parameters. So let's just quickly go through this. We got the clearance plane. I thought that was a 1/2 inch. Yeah, so probably the clearance plane got changed coming in as a template. Pay attention to that. If it is below the top of the surface, you will get a message from Cimatron saying, hey dummy, your clearance plane is below your highest point of surfaces. So we're going to change this to 0.5. And then for internal clearance, you can have absolute or optimized. Optimized can give you smaller lifts. Absolute will give you an absolute value. And then you can do additional safety in Z if you want. Sometimes it'll wrap it pretty close to the part and scare the poop out of you. So a little extra Z is never a bad thing. Okay, entry. No plunging doesn't just mean like no Z plunging, it also means no helical ramping. So probably you're going to want to use optimized here. Set the helical ramp to something that the cutter is okay with. The minimum plunge size, I like to use the tool diameter. That's TLDI times 0.3. That'll be a formula that works for every size cutter. I mean, obviously depending on the geometry of the cutter, you may want different helical plunge diameters, but a third of the cutter means that you're not going to be burning up the center of the tool, most likely. Okay, and then tolerance and surface offset. Here we're set to 30 thousandths offset, and for the surface tolerance, you know, if you have a 210 surface tolerance when roughing, you're putting out a lot of extra code that's not necessary. You can typically set your tolerance to about 10% of your offset, so that as you're leaving more material, you're not trying to follow the surfaces so critically. So I like to make the part surface 0.05 or 5% times the surface offset, which is SOFF, and then plus the normal tolerance I would use of 2/10, and that formula gives me 1/1000 and 7/10 surface tolerance. If you right click here and say show short names, here's the parameters that I have a lot of them memorized. So part surface offset has a short name called SOFF. So over here in the formula, I say 5% of SOFF plus 2/10 gives me surface tolerance that will always be related to the amount of material that I'm leaving. So if I change this to 0, guess what I get? 2/10 tolerance. Change it to 10/1000. My surface tolerance is now 7/10. So that's why I like to do that, because it always follows it and updates it. Okay, next, tool trajectory. We go to advanced. We're going to do mixed plus climb final pass. Strategy is optimized. Vertical step is fixed plus horizontal planes. Fixed vertical step is going to be a TLDI times 0.03. Okay, and then side step is going to be TLDI times 0.6 or 60%. No Z limits. No machine between layers. High speed machining, we'll go to basic. And that's a Formula 2 that should work good. Clicking between passes is basic. This all should be good. We go over here to the last page, machine parameters. And we're going to go to the access page. So we want to care about the surface feed. So this is a pre-hard material at 40 Rockwell. That means I want my surface feed to be around between 300 and 500. This cutter says it has 2 teeth. I'm going to set the surface feed to 300. And we're going to set the feed per tooth to be about 12 thousandths. Let's see what that does. Yeah, that's not good yet. Let's keep going up. 400, 450. And let's go 15. Alright, that looks better. So we're doing 450 surface feed per minute. That gives me RPMs of 1375. Feed per tooth is 15 thousandths or 40 inches a minute. Alright, and we're going to save and close. And then save and calculate. Alright, and while that's calculating, we're going to right click and say copy, paste. And then we're going to change this one to be horizontal planes finish. By the way, that option won't be available unless you have this parameter turned on. Let me show you. Under Tools, Preferences, General, general NC, you gotta have this rough volume pocket horizontal planes finish option turned on. And upon doing so, when you are in rough spiral and you go to the vertical step type, you'll see an option here called horizontal planes finish, and that's basically floor milling. So we change the offset from basic to advanced. We leave 30 on the walls as before, but we set this to 0 and choose save and calculate, and we will get just the floor to finish the floor's path. But it's done in roughing, so it starts like inside and goes outside, or starts outside and goes inside. It's intelligent start locations based on the stock that's on the block. Okay, now let's take these two and copy and paste. Oops, sorry. Paste. And then over here, let's change the cutter. And let's take a 1/2 inch. Let's make that a bowl cutter. Okay. And then change this one to a 1/2 inch bowl cutter. Remember all the formulas that we built based on tool diameter, those are all going to work. I'm not going to change anything except the RPM and feed rate. So we're going to go to the RPM and feed rate, and we'll go 2500 and 60. We'll check where that ends up being. We're at 330 surface feet per minute, 12 thousandths feet per tooth. Should be good. Save and close. Save and close. Change this one also. So this one is the floor milling. So we'll do 2030. Save and close. Although, really for the floor milling, I should have went to 40% on the step over. So we'll change it here. Save and close. And then also here, 40%. Save and close. Save the file. And then let's do a copy and paste of these two guys. Whoops. And just for sake of demonstration, let's grab a 1/4 inch cutter. And make that a bowl. This one, Save the file and calculate, and you'll see how cool this is. Incidentally, you'll see that I didn't define how this is being held, and because the stock was set to below the bottom, we're getting tool pass below the bottom. So if it's in a vise, we had a bad day, but that's what the software does. It cuts the stock as defined unless you tell it otherwise. So we could put a Z limit there if we had to keep that from going all the way down. But they gave us what we asked for. Here's the floor milling with the 1.25" cutter. If we look at the remaining material, you can see that the floors are done. But here's a good example. An 1.25" cutter can only get so far on that flat, and it's going to leave a cusp there, right? So that's why we're going smaller in diameter to get more of this flat established. So here's the 1/2" remachine where we're taking the same 30 thousandths off the walls. It's going to just cut where the 1.25" cutter didn't go. And obviously if I change that to be a 20 thousandths offset on the walls, it's going to recut the whole block, right? So here's the floor milling with the 1/2" cutter where it's getting tighter into the corners. It's almost like a rust milling for floors, right? And 1/4 inch is processing, so we're doing the same thing. Now obviously in the real world I'd probably be getting closer. I wouldn't be leaving 30 thousandths with a 1/4 inch cutter. But I also don't want to cut the whole block with a 1/4 inch cutter, right? Roughing. So sometimes what I'll do is in between the 1/2" cutter and the 1/4 inch cutter, I might go to a 3/8 ball and do a semi-finished procedure and cut all the 3D to within a few thousandths. And then when I recalculate the 1/4 inch bowl, it's only going to go where there's stock, and there won't be material where the semi-finisher went. We can probably do that real quick for the sake of example. Let's let this calculate. Well, let's do this. We'll start the parameters down here with a new procedure. In fact, I probably can pull a template. Let's go templates, apply. See what we got for a finished procedure. Here we go, semi-fin, 3/8 ball nose. And we wanted to talk about this anyways. So in this case, we're going to go to the so it's picking up the check surfaces already. Based on the template, it knows that the horizontal planes are supposed to be check faces for this particular procedure. And for the part surfaces, this set should be 3D. And probably caps. Okay, so there there's the I don't know why. I guess maybe I didn't have these on the right set. I don't know. We'll just add these in real quick. Okay. Excuse me. And I want these two to be check faces. Alright, and then for calculation speed, I don't want the toolpath holder being considered because it'll take a long time to calculate. So we're just gonna tell it to ignore the holder for now. And save and close. Okay. And here's our 1/4 inch rougher. And then the 1/4 inch floor remachine. Uh-oh. Is that right? Yeah, I guess that's right. So that rougher must have cleared out that. And then the floor procedure cut it. That helical entry is kind of funny. I think that that comes from right here, the fixed vertical step. We can put a large value in there because we're just doing the floors. We don't need a step down. Well, I don't know why it's doing that. I'll have to investigate that further. But it should just go down and cut the floor. Alright, but what we want to look at is this one is cutting to 3/1000ths away, and we're going to do a cut and paste here, and then we can change the offset for the 20/1000ths cutter to be 10/1000ths. And where that normally would recut the whole block, it's not going to, because we're allowing the 3/8 cutter to update the stock model. Update your stock model, yes. And then save and close. So when the 1/4 inch recalculates, it'll consider that there's 3/1000ths of material left and it's staying away by 10. So it's only going to cut where there's material. So this might take a while to calculate, but let's go ahead and launch it.